Hello, sir.
Hi, good day, good evening, okay, good morning for the others who is watching this webinar in other places. Okay, so magandang buhay. Yan. So that's how we greet in our school, in our division here in Angeles City. Magandang buhay means good life. Okay, so let me repeat that one. Magandang buhay. So when you saw your colleague, you greet him or you greet her with that phrase. Magandang buhay. Okay? So I am Sir Ben. I am a mathematics teacher at Angeles City National High School. So I would like to take this opportunity to thank Sir Nestor Nuesca for giving this opportunity, and also Ma'am Malang, our our supervisor in mathematics, for this rare opportunity to share my knowledge not only in our country but also in other countries as well. Also, I would like to thank Sir Ike Prudente for giving me the go signal to share this topic. I've learned this topic from his webinar last year, and I am so lucky that I attended that webinar and I learned so much, and I'm so much excited to share this one to you. Okay, so let us start this webinar. Okay, so this webinar will focus on the identities. So identities, it focuses more on the subject trigonometry. Okay, so to be specific, the topics will be common difference identities, double angle identities, and half angle identities. So for those who already have an idea about this topic, you might think that I'm going to discuss the formulas. So these are the formulas. As you can see, for those who are not yet familiar with these identities, you will see the formulas somehow confusing. Yes, they are easy to memorize for some, but not for all. This is so confusing. Okay. Those are the formulas for the sum and difference identities. Then we also have double angle identities, and then we also have these half angle identities. So counting all of those formulas, we have 16 formulas. If you are a student, if you are not that, if I say you are not a math enthusiast, you will really have a hard time memorizing those 16 formulas. Now, in this webinar, the topics that I'm going to share to you right now, guys, is somehow, if I may say, an easier, much easier way in dealing with sum and difference identities, double angle identities, and half angle identities. Okay, so let us start with this example. So sum and difference identities. So suppose that alpha and beta are angles in standard position with sine alpha is equivalent to 4/5 and cosine beta is equivalent to -5/13, where alpha is in the first quadrant and beta is in the second quadrant. Determine the value of sine alpha plus beta and cosine alpha plus beta. So just like what I've said a while ago, we are not going to use a formula here. So the first thing to do here is to somehow illustrate the given example here. So we have here a Cartesian plane. So let's start with the first angle, alpha. So in that case, we're going to draw a triangle. So the angle here would be that one. Okay. So let me use a pointer here. Okay, so this one, this is alpha, and then it says here that sine alpha is equivalent to 4/5 or 4/5. So it means that applying the trigonometric ratio, 4 is actually the opposite side of alpha, while 5 is actually the hypotenuse. Then, for us to identify this side, the measurement of this side, we're just going to use the Pythagorean theorem. Okay, so applying that theorem, we will get 3 for that side. So triangle, the first triangle is already complete. For the second triangle, we'll do it this way. So it says here that beta is in the second quadrant. So that triangle will be on the second quadrant. So this is the angle. So cosine beta is equivalent to -5/13. So in that case, cosine, applying the trigonometric ratio, 5 will be the adjacent side, while 13 will be the hypotenuse. Remember this one, in in a Cartesian plane, the hypotenuse is always positive. So in that case, 5 will be the negative number. In that case, this part will be -5, and then the hypotenuse will be 13. For us to identify this part, definitely we're just going to use the Pythagorean theorem. So applying that theorem, we will get 12 for that side. Now, the triangles are now complete. The next thing to do is to create a table. So how are we going to create a table? This one. Okay, so focus on the sequence of the words. The first one would be angle, and then the adjacent side, and then the opposite side, and then the hypotenuse. And then for the first column, we will write the angles: alpha, beta, and alpha plus beta. For those who are watching right now, I am requesting you to somehow get a paper or scratch paper and a ball pen so that you can write the table. You can copy the solution here, because later on, we're going to give certificate for those who will get will give certificates for those top 3 scorers. Okay, so the questions for later will be focusing on the discussion right now. Okay, so I'm going to use Kahoot for the online quiz later. So again, get your paper and your writing material so that you can write the solutions for this one. Okay, so again, just like what I said a while ago, the questions later will be focusing on the examples that I am presenting right now. Okay? Now, for the adjacent side, opposite side, and the hypotenuse of alpha, that is just simply 3, 4, 5 respectively. For beta, same, -5, 12, and 13. Now, if we want to add the angles and we want to identify the adjacent side, the opposite side, and the hypotenuse of alpha plus beta, this is the thing that we're going to do. Follow this one. First, we're going to multiply these 2 numbers. So 3 times -5 is, okay, you are correct, that is -15. Next, we're going to multiply these 2 numbers. 4 times 12, that is, okay, you are correct again, that is 48. And then, for adding angles, what we're going to do with the adjacent side is we're going to add the 2 products. So we will have now -15, we're going to subtract the 2 products. Okay, so we will now have -15 minus 48, and what will be the answer? Okay, you are correct. So that would be -63. So for the opposite side of alpha plus beta, this is the process that we're going to do. You multiply these 2 numbers. Okay, so 4 times -5, that is, okay, you nailed it. So that is -20. Next, you multiply these 2 numbers. So what will be the answer? Okay, you got it right. So that is 36. And then we're going to proceed to addition. So -20 plus 36. Okay, you are in a row. So that is 16. For the hypotenuse of alpha plus beta, what you're going to do here is just multiply the hypotenuse of alpha and beta. So 5 times 13, and that will be correct, 65. Now, looking at the table right now, we already completed the adjacent side, the opposite side, and the hypotenuse of alpha plus beta. So how are we going to identify sine alpha plus beta and cosine alpha plus beta? So by applying now the trigonometric ratio. Isn't it that sine is equivalent, or sine theta is equivalent to opposite over hypotenuse, while cosine theta is equivalent to adjacent over hypotenuse. So we're just going to apply that concept. So in that case, sine theta now, or sine alpha plus beta now, will be equivalent to its opposite over hypotenuse, and that will be 16 over 65. That's it. And for cosine alpha plus beta, that would be adjacent over hypotenuse. So adjacent will be -63, and the hypotenuse is 65. So the answer now will be -63 over 65. That's it. So we identify the value of sine alpha plus beta and cosine alpha plus beta without using that formula. So that is the good thing about this process. We do not need to memorize 16 formulas as I've presented a while ago. What we need to remember is only the process. And come to think of it, we are just simply using basic concepts, basic skills. How did we get -63? We just simply add, we just simply multiply 2 numbers and then subtract. How did we get 16? We just simply multiply 2 numbers and then add. How did we get 65? We just simply multiply numbers. So what are we just simply using here is actually addition, multiplication, and subtraction of integers. As simple as that. And then applying the concept of 6 trigonometric ratios. Okay? So comparing this method in memorizing the formulas, for me, I can say that this is a lot easier. And I think maybe 90% or maybe 80% of those who are watching right now will agree to me that this one is a lot easier compared to the, if I may say, the old method. Okay? So, how come this process is applicable? Let me show you the proof for that one. Okay? So, say for example, we want to add angle alpha and beta. So, for me to add that one, we're going to construct a figure so that they will be combined. So, that figure would be this one. Okay? Now, just going to label the vertices. And then, our goal here is to create a right triangle wherein it consists of the angle alpha plus beta. So, in that case, we will have this broken line. Okay? So, focus on this triangle. In this triangle, we need to identify the measurement of RS and OS. As you can see here, I marked the right angles here so that later on when I will show you the proof, it will be somehow more easier to understand. Okay, so again, our goal here is to identify the measurement of OS and RS. Now, what concept are we going to apply here? We're going to apply the concept of similar triangles. Okay, so let us start with this one. So we know that OS plus SP is equivalent to OP. So that is the segment addition postulate. OS plus SP. OS plus SP is equivalent to OP. Okay? Now, OS, again, just like what I've said a while ago, we need to identify the value of OS. So OS is equal now to OP minus SP. So we apply here the addition property of equality. So we added negative SP on both sides of the equation. Okay? Now, notice this one. TQ is equal to SP. Why? TQ is equal to SP simply because this one is a rectangle and the opposite sides of a rectangle, the opposite sides of a rectangle, they are equal. So in that case, by substitution, we can now say that OS is equivalent to OP minus TQ. Next, OS now is equivalent to 12 minus TQ. So OP, the measurement of OP is 12, okay, based from this part. Okay, now we can now say that triangle OPQ is similar to RTQ. Why? Definition of similar triangles. Two triangles are similar if their corresponding angles are congruent and their corresponding sides are proportional. Now, look at this triangle. OPQ, where is OPQ? OPQ, the bigger triangle, this one, okay, is similar to RTQ, this triangle. Now, how are they similar? This one is equivalent to 90 minus beta. And applying the vertical angle theorem, this one will be also 90 minus beta. Since this is a right triangle, this part only is equivalent to beta. Again, this is a right angle. So this one, by angle addition postulate, this will be 90 minus beta. And definitely this will be beta. So in that case, I showed you that triangle OPQ is similar to triangle RTQ. Now, since they are similar, we can say that their corresponding sides are proportional. So in that case, we can now say that PQ over TQ is equal to QO over QR. So PQ, where is PQ? This one, PQ over TQ is equal to QO, the hypotenuse, over QR, the hypotenuse of the smaller triangle. Now, let us substitute the values of each segments. PQ is equivalent to 9. And then we need to identify TQ. So TQ still will remain that one. QO now, the measurement of QO is 15. And the measurement of QR is 8. Now, solving for the value of TQ, it will be like this. So 9 times 8, that would be, correct? That would be 72. So TQ now will be equivalent to 72 over 15. So I won't express that fraction into lowest term. Later, you will see why. Now, substitute PQ by 72 over 15. So OS now will be equal to 12 minus 72 over 15. And solving that one, OS now will be equal to 108 over 15. So remember that one. OS is equivalent to 108 over 15. Let us proceed. So we already have the value of OS. Let us now identify the value of RS. So same process. RS is equivalent to RT plus TS. RS, this whole broken line, is equivalent to RT plus TS. Okay, by segment addition postulate. Next, TS is equal to QP. So this is a rectangle, right? So that means that we can substitute TS by QP. QP is 9 based from this illustration. Now, let us identify the value of RT. How? Using the what do you call this? The concept of similar triangles. So RQ over OQ is equal to RT over OP. So RQ, the measurement of RQ is 8. OQ is 15. RT, that's the one that we are identifying. So RT will remain the same. OP now will be equivalent to 9. OP is 12, I mean. So solving for RT now will be equivalent to 8 times 12 over 15. And simplifying that one, that will become 96 over 15. So we already have the value of RT. What are we going to do here? Change the value of RT by 96 over 15. So 96 over 15 plus 9. So that will be 231 over 15. And that is the measurement of side RS. Now, focus now on this triangle. The one that I marked as the red triangle right now. So removing the excess parts. Okay. Now, this is now A plus B. So that's our goal. Now, what's the measurement of RS and OS? Okay, that's great. You still remember the measurement of those two sides. Now, what we do here is we want the sides to be integral, meaning the numbers or the measurement of the sides must be an integer, or if I may say, I mean a whole number. Okay, so it starts from 1 to positive infinity. Okay, so what are we going to do here is to multiply the three sides by 15. The triangle, even though I multiply it by a number, it won't change the triangle itself. It will change, yes, it will become bigger, but still, this triangle and the new triangle that will be produced are just simply similar. Okay, so nothing to worry about that one. So let us multiply the three sides by 15. So in that case, ayan. So the measurement of the sides will be 108. So the adjacent side of A plus B or alpha plus beta is 108. The opposite side of alpha plus beta is 231. And the hypotenuse will be 255. Relating it to the table a while ago, we can still achieve this one. How? Let us apply the one that I did a while ago. So first, multiply this two. So 15 times 12 and then multiply this two also. So 15 times 12, that is 180. 8 times 9, that is, okay, you are correct, 72. And then proceed to, okay, that's great. You remember it clearly. We will proceed to subtraction. So 180 minus 72, you are correct again. So that is 108. Okay, next, for us to identify the opposite side, we multiply these two first. So 8 times 12, okay, you are correct, 96. And this one, we multiply these two numbers. Okay, you are again correct. That is 135. And then we proceed to, okay, nice one. That will be positive. So we will proceed to addition. So 96 plus 135, and that will be great. So that is 231. If you will notice, we are arriving at the same answers, comparing the answers from the figure that you are seeing right now. And definitely the hypotenuse. What are the numbers that we are going to multiply to identify the hypotenuse? Okay, correct. We are going to multiply the hypotenuse of alpha and the hypotenuse of beta. So that will be 17 times 15, and that will be 255. So the process itself, it really works, okay, by using the concept of similar triangles. Okay, let us proceed. Now, if we want to deal with the difference of two angles, okay, so the different, you see that we are dealing here with sum and difference identities. The one that I've explained a while ago is the sum identities. Right now, the difference identities. The process here is just simply the same. The way we prove sum identities is simply the same with the proving of the difference identities. Now, for the process, still the same. The numbers that you will multiply, they are just the same. The only difference will be the signs. Okay? So when we are subtracting the two angles, for the adjacent side, we will add the products. For the opposite side, we will subtract the products. While for the hypotenuse, it will be the same. Okay? So in that case, if we want to identify the adjacent side of alpha minus beta, that would be 180 plus 72. That would be, okay, you are fast. So that would be 252. And for the opposite side, and that will be negative 39. So let us have an example regarding the difference identities. So let us use the same, the same example a while ago so that we can maximize the given example. So let us identify the value of sine alpha minus beta, the value of cosine alpha minus beta, and the value of tangent alpha minus beta. Okay? So in that case, let us apply the concept of the difference identities, I mean. So in that case, so how did we get negative 15 here? We multiply these two. How did we get 48 here? We multiply the two opposite sides and then we proceed to addition. How did we get negative 20 here? We multiply these two numbers. We cannot interchange these two, ha? Okay? So we multiply these two numbers and that would be negative 20. How did we get 36? That is 3 times 12. And then we proceed to subtraction. For the hypotenuse, we achieve 65 by just simply multiplying 5 and 13. So simplifying this one, that would be 33, and negative 20 minus 36, that will be correct, negative 56. We now have the adjacent side of A minus B. We now have the opposite side of alpha minus beta. We now have the hypotenuse of alpha minus beta. We can now easily identify the value of sine alpha minus beta, cosine alpha minus beta, and tangent alpha minus beta. So applying the trigonometric ratio, sine theta is equivalent to opposite over hypotenuse. So the opposite side is negative 56. The hypotenuse will be 65. For cosine, let us apply that. Again, the trigonometric ratio, cosine theta is equivalent to adjacent over hypotenuse. So in that case, okay, you are correct. That will be 33 over 65. And last, for tangent alpha minus beta, okay, so I am very much confident that you already know how to do this one. Tangent alpha minus beta will be equivalent to, correct, negative 56 over 33. Okay, so as you can see, it is really easy. Compare it to memorizing 6 formulas. Okay, let us now proceed to another examples. So let us identify the exact value of cosine 15. If you're going to use a calculator, you can already identify the value of cosine 15 degrees. But definitely in a classroom setup, most of the classes are not allowed to use calculator. Okay, so how are we going to identify the value of cosine 15 without using the formula and without using the calculator? So we know that cosine 15 is actually the same with cosine 45 minus 30. So in that case, what we're going to do here is to apply the concept of difference identities. Okay, so let us create a table. So the adjacent side of a 45, the adjacent side, the opposite side, and the hypotenuse of a 45 degree triangle, 45, 45, 90 triangle will be like this. 1, 1, square root of 2. While for a 30, 60, 90 triangle, the adjacent side of a 30-degree angle, the opposite side of a 30-degree angle, and its hypotenuse will be square root of 3, 1, and 2. Now, since we are subtracting two angles, what we're going to do here is to first multiply these two numbers, and that would be, correct, square root of 3. Next, correct, we multiply these two numbers. That will be 1. And then proceed to, okay, correct, you remember it very clearly. So that is, we proceed to addition. Next, for the opposite side of 15 of a 15-degree angle, so what we're going to do here is to multiply these two. I'm sorry for that one. I just carried away. Since we are just simply identifying the value of cosine 15, we don't need to identify the opposite side of a 15-degree angle. Why? Since cosine is equivalent to adjacent over hypotenuse, we don't use the opposite side. So to save time, we will just simply identify the hypotenuse of a 15-degree angle. In that case, multiplying those two, that would be 2 square root of 2. Now, cosine of 15 will be equivalent to adjacent. So that is square root of 3 plus 1 over hypotenuse, which is 2 square root of 2. So what we're going to do here is to, simplify this one. So we rationalize that fraction. We multiply the numerator and the denominator by square root of 2 over 2. No worries, we are not changing the value simply because we are just simply multiplying that fraction by 1. Square root of 2 over square root of 2 is equivalent to 1. So we are actually applying the identity property of multiplication. In that case, that would be square root of 6 plus square root of 2 over all over 4. Next example. So what is the exact value of sine 255 degrees? So in that case, sine 255 degrees is actually equivalent to sine 135 plus 120 degrees. So how do we identify the numbers to be added? Think of the special angles. Okay? Think of the special angles. So that's how you identify the two numbers to be added. So let us create a table. So for the adjacent side, the opposite side, and the hypotenuse of a 135-degree angle will be -1, 1, and square root of 2. This is actually the same. Actually, 135 degrees is actually a 45, 90 right triangle in the second quadrant. Same thing with 120. 120 is actually what do you call this? The same with 60 degrees only in the second quadrant. So for 120 degrees, the adjacent side, the opposite side, and the hypotenuse will be this one, -1, square root of 3, and 2. Now, we add the angles. So we multiply these two first, and then these two. So we will now have 1. Sorry. So I'm just simply used to completing the table. So since we are identifying sine 255, we are only after the opposite side and the hypotenuse. So we will not use the adjacent side. So for us to identify the opposite side of 255 degrees, we're just going to multiply those two numbers, 1 times -1, and that would be, correct, -1, and then we multiply these two numbers. So -1 times square root of 3, and that would be negative square root of 3, and then proceed to, correct, we are going to proceed to addition. For the hypotenuse, same process, we just simply multiply these two numbers. Square root of 2 times 2, and that would be 2 square root of 2. Now, let us identify the value of sine 255. So sine 255 is equivalent to its opposite over hypotenuse. So in that case, that would be -1 plus negative square root of 3 all over 2 square root of 2. So in our numerator, we can factor out the negative sign. So we can factor out -1. So this one will become -1 plus square root of 3 all over 2 square root of 2. Rationalize that one. So multiply the numerator and the denominator by square root of 2 over square root of 2, and we will get negative square root of 6 plus square root of 2 all over 4. Let us now proceed to the double angle identities. For double angle identities, I'm not going to introduce a new process here. Why? When we, see for example, if we want to double a number, isn't it that we are just simply adding a number to itself? Okay, so in that case, double angle identities is just simply using the sum identities, the first example that I presented a while ago. So let's proceed to the example using the double angle identities. So if tangent x is equal to 2 and cosine x is less than 0, identify the value of sine 2x and tangent 2x. So same process from the sum identities. So let us create a table and let us use this Cartesian plane. Okay. So for the Cartesian plane, it says here that tangent x is 2. So it means that tangent x is positive. Tangent is only positive at the first quadrant and the third quadrant. The other condition is that cosine x is less than 0, meaning cosine is a negative number. Cosine is negative in the second quadrant and the third quadrant. So in that case, these two will meet at the third quadrant. That is why our triangle is drawn like this. Okay, so this will be x. Tangent x is 2 over 1. Tangent x, 2 will be the opposite side, 1 will be the adjacent side. So in that case, since we are on the third quadrant, the adjacent side would be -1. The opposite side will be -2. While the hypotenuse, we're just going to apply the Pythagorean theorem. So in that case, our hypotenuse now will be square root of 5. So in that case, let's just fill this table. Okay, so adjacent is -1, opposite side will be -2, the hypotenuse would be square root of 5. Same thing with this one kasi simply because they're just the same, x and x. So in that case, the adjacent side, opposite side, and hypotenuse are just the same. So let us use the process a while ago. We multiply these two numbers. That would be 1. And then multiply these two numbers. Correct? That would be 4. And then proceed to, correct, minus. So 1 minus 4, that will be, you're correct, negative 3. Next, for the opposite side of 2x, so we multiply these two numbers. So that would be, okay, you are correct, 2. And then multiply these two numbers. Okay, you are also correct. That would be 2. And then proceed to, okay, you nailed it right, addition. So 2 plus 2, and that will be 4. And then for the hypotenuse of 2x, we simply multiply these two numbers, and we will get, correct, 5. So you will notice here that this three numbers are actually Pythagorean triples. Same with the numbers that we attained a while ago. The numbers that we are attaining on the last row are all Pythagorean triples. Okay. Now, let us now identify sine 2x and tangent 2x. Sine 2x is equivalent to opposite over hypotenuse, and that would be 4/5. For tangent 2x, that would be opposite over adjacent, and that would be, correct, negative 4/3. Okay? Next, we're down to our last topic, half-angle identities. For half-angle identities, it is somehow different. Okay? The process here is somewhat different from the first three. Okay? Let me show you why is it different. So for half-angle identities, so for the adjacent side, say for example, the adjacent side of a given angle is x, the opposite side of a given angle is y, and the hypotenuse of a given angle is r. The adjacent of half of that angle will be x plus r, the opposite will be just the same, and for the hypotenuse, we will just simply use the Pythagorean theorem. Now, Sir Ben, how come that the adjacent side of a or alpha over 2 is x plus r, and the opposite side of a over 2 is just the same with the opposite side of a or alpha? Let me show you. Let us use the concept. Actually, this was discussed by the first speaker a while ago. So we're going to use the concept of a circle. So let us draw a triangle wherein it has the angle alpha. Okay? So that shaded angle, the measurement of that shaded angle is actually alpha. Next, let us draw this triangle. So we will now have two chords. Okay? So notice that that angle, the one that I shaded right now, is actually an inscribed angle. If you still remember the topic a while ago, the measurement of the inscribed angle is just simply half of its intercepted arc, while the measurement of the intercepted arc is actually equivalent to the measurement of the central angle. So in that case, we can say that the measurement of the inscribed angle is just simply half the measurement of the central angle. So in that case, this will be now equivalent to alpha over 2. Okay? Now, notice this triangle, that red triangle. That red triangle now, this angle now is actually equivalent to alpha over 2, correct? Now, this part is actually the radius of the given circle. So you will notice now that if this red triangle, the adjacent side is actually equivalent to r plus x or x plus r, while the opposite side is actually equivalent to y. So that is the reason why the adjacent side of alpha over 2 is x plus r, the opposite side of alpha over 2 is y. So for the hypotenuse, just like what I've said a while ago, we will just simply use the Pythagorean theorem. Okay? So let us proceed to the example. So we have here this figure. So based from the given figure, determine the value of cosine beta over 2 and tangent beta over 2. So let us create a table. So for the adjacent side of beta, that would be 3. For the opposite side of beta, that would be 4. And the hypotenuse of beta, that would be 5. Now, let us apply the formula that I showed you a while ago on the previous slide. For the adjacent side of beta, that would be x plus r. In that case, that would be 3 plus 5, and that would be 8. For the opposite side of beta over 2, same with the opposite side of beta. That would be 4. And for the hypotenuse, we're just going to apply the Pythagorean theorem here. I'm going to give you 10 seconds to identify the hypotenuse. What do you think would be the hypotenuse of beta over 2? Okay, so you are so fast in determining the measurement of the hypotenuse. So the hypotenuse is, yes, you are correct, 4 square root of 5. So how are we going to identify cosine beta over 2? Just simply apply the trigonometric ratio. Cosine is equivalent to adjacent over hypotenuse. So in that case, that would be a. Sir Ben, how come it became 2 square root of 5 over 5? Actually, that is 8 over 4 square root of 5. Rationalizing that one and then simplifying it, it would become 2 square root of 5 over 5. Sir Ben, how come there is a symbol here, a positive negative sign? Remember this one, an angle, given angle. Say, for example, the given angle is A. A is actually equivalent to 360 plus A, correct? So if you were going to identify half angle of A, say for example, A is in the first quadrant. Half of A is also in the first quadrant. A plus 360, if you get half of that one, that would be located on the third quadrant. So in that case, we will have two values here. One will be positive and the other one would be negative. The concept that is being applied here is actually getting the square root of a number. Say for example, you want to identify the value of square root of 9. We don't just simply say 9. We don't just simply say 3, but we say positive negative 3, because 3 times 3 is 9 and negative 3 times negative 3 is 9. So that is the concept that is being applied here. Why is that we have positive and negative sign here? For the tangent beta over 2, that would be opposite over adjacent. So that would be 4 over 8 or 1/2. Okay? So that's it. That is the topic about sum and difference identities, double angle identities, and half angle identities without using a formula. I would like to take this opportunity to inform the viewers about the International Vedic Mathematics Olympiad. So as you can see on our screen, the details, you can screenshot here or you can take a picture of this one, or you can visit the page of Math Advocate Ike, or you can check the page here and also this page. So this will, just like what Sir Ike said to me, there are a lot of questions that focuses on the topics that I've discussed in this webinar. So this is a great chance, great opportunity to show your learnings about this webinar. Okay? So I hope that you learned something, and I hope that you will use this topic in the near future, especially for the math enthusiasts that are watching right now. Okay? So with that, I'm going to share the quiz. So 10-item test. Go to kahoot.com or just simply search in Google Kahoot. Then I'm going to share the link. Okay. So I'm just going to stop sharing the presentation. This is actually the end of the presentation. So with that, if I may say, maraming salamat. That is thank you in Philippines. In Kapampangan, dakal pong salamat. Ken pa makiramdam. Okay. So what I've said